Okay, the last solving video here has to do with a couple other methods for solving quadratic equations. This first one, solving with square roots, we use if we only have a single variable term. Okay, so when we did solving by factoring, we usually had in our trinomial, we'd have like an x squared and an x term and then a constant. But here, this is when we only have the squared term. Okay, and our process here is to use the order of operations backwards. So we're going to start with adding and subtracting. Is there anything that we can add or subtract that gets us closer to isolating our variable? And then is there anything we can multiply or divide? And then we get rid of the exponent, the square on the squared term, and then lastly, if there's anything with grouping symbols, we do that at the end. Okay? So looking at this first example, the first thing I'm going to want to do is move that 10. I'm going to subtract 10 from both sides. Okay, so we get 7v squared equals 112. Okay, and then multiplication and division, now we want to divide by 7 to get that away from the v squared. So we have v squared equals 112 divided by 7 is 16. And lastly, we undo the square by taking the square root. When we take the square root of both sides, we have a v on the left, and on the right, square root of 16, if I just said, hey, what's the square root of 16, the answer would be 4. But if the question is v squared equals 16, what can v possibly equal, then we need to include the positive or the negative 4. So v is plus or minus 4 for this one, okay? If you're unsure of what the difference is, anytime you're solving for a variable and you take a square root, you're going to have a plus or minus as part of your answer. If you're just evaluating an expression that has a radical in it, like, hey, what's the square root of 25, then your answer is only what's called the principal root or the positive root, which would then just be 5. Okay? All right, for this next one, we start by subtracting 1 from both sides. So we have 2m squared equals 160. Then dividing both sides by 2, m squared equals 80, and then getting rid of the square by applying a radical on both sides. We have m equals, and we do need the plus or minus. Now in this case, 80 does not have a perfect square root. I do not want a decimal, so what I want to do is simplify that radical. 80 is 16 times 5. Square root of 16 is 4, and then there's a root 5 left. If you're a little shaky on simplifying radicals, there is going to be another video that covers that, so refer to that if you need to. Okay? So m equals plus or minus 4 root 5. Okay? For this next one, I do have subtraction, but it is inside the parentheses, which means it's inside the grouping symbol, and that bumps it to the end of the order of operations backwards instead of the beginning. Okay, so in other words, it's at the top. So the first thing I want to do then is I'm going to divide both sides by 3. Okay, I cannot distribute the 3 into the x minus 2 squared. Okay, don't try to do that. Divide both sides by 3, we get x minus 2 squared equals 21. Okay, and then to get rid of that square, we take the square root of both sides. X minus 2 on the left, we do need the plus or minus on the right, so plus or minus 21. Oh, nope, sorry, plus or minus root 21. If the radical does not simplify, then just leave it like that. It's not 3 root 7 or 7 root 3, it's just root 21. And then lastly, now we take care of the subtraction. So when we add 2 to both sides, the 2 does not get added inside the radical, it's on the outside, so it's 2 plus or minus root 21. We essentially just stick it right in front there, okay? So 2 plus or minus root 21 is our answer there, okay? And that is both solutions, 2 plus root 21 and 2 minus root 21. You don't need to write them separately, though. It doesn't hurt, but you don't have to write them separately, okay? Okay, now, if we have both a squared term and a linear term, so an x squared and an x, and then a constant, but it's not a factoring problem, then we can use what's called the quadratic formula, which you're probably familiar with. Maybe you learned a little jingle along with this, like to the tune of Pop Goes the Weasel or something like that, but this is a very useful formula. Now, the thing with the quadratic formula is it will always, always work for solving any type of quadratic equation that is in standard form. However, it's not always the most efficient, So my suggestion, if you have a question like the x squared minus 7x plus 3 equals 0, is start by seeing if it can factor. If it can factor, that's going to be faster. But if you can't factor, then go ahead and use the quadratic formula. Okay? So plugging the values into the quadratic formula, I do need to identify what a, b, and c are. And since this is my standard form, okay, a is the coefficient of the x squared term, b is the coefficient of the x term, c is the constant, as long as it is set equal to 0. So for this first one, my a is 1, b is -7, don't forget the sign, c is 3. So I'm going to plug those into the quadratic formula. So x equals, and then since this is the opposite of b, that's going to be +7, plus or minus the square root, -7 squared is 49, minus 4 times 1 times 3. All of that is over 2 times 1. Okay? And then we apply the order of operation to simplify that. So 7 plus or minus, okay, so we have 49 minus 4 times 1 times 3 is 12. Okay, 49 minus 12 is going to be 37. And if you want to do this in 2 steps, you can. I'm combining those 2 steps. All over 2. Since root 37 cannot be simplified, I am done. I cannot go any further. Okay? I cannot reduce anything, so I have to stop right there. Even if the 7 and the 2 had a common factor, which in this case they don't, I cannot reduce those unless something can be simplified from the root 37, and it also has a common factor. Okay? So if I can't take anything out of the radical, then I don't even need to look at the other 2 constants because I cannot reduce them. All right? One more example here. Now, this one is not equal to 0 yet, so I'm going to subtract 9 from both sides first. So that it is equal to 0. Now my a is 3, b is 4, and c is -9. Okay? So I'm going to come over here to the right for this one. So p equals -4 plus or minus the square root of 4 squared, which is 16, minus 4 times 3 times -9. Notice I'm using parentheses when I multiply by a negative. Be careful there. All over 2 times 3. Okay, and then order of operations, I need to look inside the grouping symbol here. So -4 times 3 times -9. It does not really matter what order you multiply those in. Okay, but you need to make sure that both of those, that you change that to a positive, okay? So we have 4 times, so we could do this a couple ways. So let's do, I'm going to do 3 times 9 is 27. 27 times 4, well, 27 times 2 is 54. Doubled again is 108. So that's going to be 108 plus 16. Okay, so -4 plus or minus root 124 all over 6. Okay? Now, 4 and 6 do have a common factor, but again, I cannot reduce those until I check to see what whether or not the 124 can be simplified. In this case, I'm going to check to see if 4 goes into it, because that's perfect square. Half of 124 is 62. That's even, so I can do half of that again is 31. So yes, I can reduce that, or not reduce that, sorry, I can simplify the root 124 and make this -4 plus or minus 2 root 31 over 6. And now, because I have a common factor, hold on a second here, because I have a common factor here, here, and here, then I can reduce. I can take a 2 out of all of those. So I get -2 plus or minus root 31, or 1 root 31, doesn't matter, all over 3. Okay? And then that's my answer. Okay. The last method here, completing the square, is one that you might not be familiar with. If you watch the factoring video, the last thing we talked about was the perfect square trinomial. We came up with this formula here. And what we're doing is we're trying to basically force the trinomial to be a perfect square. So in other words, we're trying to force the first term to be a perfect square and this one to be 2 times a middle term. And the way we're going to do that is we're going to actually change the constant. Still following the rules of algebra, we're going to change the constant so that it turns into a perfect square, because then we can use the square root method we used at the beginning of this video. Okay? So let me show you what I mean real quick before we do those examples. Let's say we had x squared plus 6x, okay? Just those two terms and then something else here. And the question is, what would have to go in that blank space in order to make this a perfect square trinomial, okay? Well, because of the formula, because of this pattern, we have a squared as our first term, that's x squared, so that means this would be an x. Okay, and then this middle term is 2 times a times b. Well, I already know that a is just the x. Okay, so 6 is 2 times what? It's 2 times 3. So that means there needs to be a 3 as our b value. Okay, again, looking back at the a plus b squared formula, in order to have x squared plus 6x as the first two terms, we need x plus 3 as our quantity that gets squared. Okay. Or in other words, we take this and we divide it by 2 to see what goes here. Okay? Now, we are setting the third value, and the third value is b squared, so that means there's a 9 here. Okay? So by rewriting x squared plus 6x as the quantity x plus 3 squared, we actually added a 9 that was not there to start with. Okay? So we can do one of two things to keep the rules of algebra. We can either subtract 9 as well, okay, so then we would just have a minus 9 at the end, or if there were an equal sign, like the two that we're about to do, we can just add 9 to the other side of the equation as well. Okay, but either way, you need to make sure that you keep things balanced, and it'll make a little more sense here when we do this equation. Okay, so I'm looking at n squared minus 14n plus 3. And I'm going to ignore that 3 for a minute and just look at the first two terms. And in fact, I'm going to rewrite it with a space. Okay, so that looks like the one I just did. So n squared minus 14n, and I'm going to put a space here. Okay, I'm also going to go ahead and move that 3 to the other side. Okay, so I have a negative 3 on the right because, like I said, I'm kind of ignoring that constant, and I'll force it to be what I need it to be. But I'm going to put the blank over here as well, because remember, if I add something in the first blank, I need to add the second thing, or add the same thing to the blank on the other side of the equation for the equation to stay balanced. Okay? So now I'm looking at the n squared minus 14n. Okay? And I want to write that as a perfect square. Perfect square trinomial. So n squared minus 14n plus something is going to become, and I know I need an n here, okay? It's going to be subtraction because the 14 is negative. And now the question is, what goes here? What goes here that would give me a 14 as my middle term? And like we said before, it's going to be half of that, so that means a 7, okay? Now, n minus 7 squared is not n squared minus 14n. It's n squared minus 14n plus what? Plus 7 squared, which is 49. So by changing from this expression to this expression, we have added a 49 that didn't used to be there. Okay? Not a problem if we go ahead and add 49 on the other side as well. So these three terms, the n squared minus 14n plus the 49 that didn't used to be there, are equal to this expression. Okay? Are equal to this expression. So don't write another plus 49 here. It's not there. Okay? The plus 49 has been sucked up into the n minus 7 squared. Okay? So we have equals, and then over on the right side, negative 3 plus 49. We do have a 46 left there. Okay? So now we have a form that if you go back and look at the top, looks like one of these where we solved with square roots. In other words, order of operations backwards. Okay, in fact, it looks like this third one more. Okay, so let's go ahead and finish solving here. There's nothing to add or subtract. There's nothing on the outside to multiply or divide. So we take the square root of both sides. N minus 7 equals plus or minus root 46. That cannot be simplified, okay, so we leave it plus or minus root 46. We do need to add 7, and remember the 7 is going to go in front of the plus or minus because it doesn't get combined with the radical. So n equals 7 plus or minus root 46. And those are our two answers. Okay. One more. Oh, hold on, everything shifted. Okay, let me move that. Sometimes when I slide up and down on the screen, it moves things. So let me see if I can clean that up. Pretty close. There we go. Okay. So now I'm looking at the z squared plus 12z, maybe? Nope, not going to let me move it. Okay, 12z equals 4. That 4 is already over on the right. Let's use that color. 4 is already on the right, so I do need to rewrite this, and I'm going to leave a space for the constant that gets added. Excuse me. So z squared plus 12z plus a blank equals 4 plus blank, and I did not leave myself enough room. There we go. Okay, so z squared plus 12z. I'm looking to make that into a perfect square. So z, because this is positive, this is plus, and again, half of that middle term, so this is a 6, which means we've added a 6 squared. Okay, but to keep the algebra part balanced, keep the equation balanced, I need to add 36 on the right side as well. So now these three terms become z plus 6 squared, and on the right I have a 40, 4 plus 36. Okay, so that's the completing the square step. Now I need to solve. So again, I'm going to take the square root of both sides. Z plus 6 equals plus or minus. In this case, I can simplify the square root of 40. That's 4 times 10, so 2 root 10. And then we subtract 6. So we have z equals negative 6 plus or minus 2 root 10 is our final answers. Okay? Let's see, one more thing that did not come up on any of these, but it might come up in your homework, so I'm going to go ahead and add it. If you have, if you're solving with radicals and you end up, let's say we have x plus 1 squared equals, and let's just say we have 25 over here, okay, something that is a perfect square. When you get to the solving part, when you take the square root and you have plus or minus 5 over here, because that's a whole number, it can be combined with the negative 1 when we subtract that. So I don't want you to leave your answer as negative 1 plus or minus 5. I want you to actually evaluate that, okay? Negative 1 plus or minus 5 is two different values. It's negative 1 plus 5 or negative 1 minus 5. So that's going to be a positive 4 or a negative 6, okay? It is not equal to plus or minus 4. You can't just subtract 1 from the 5 and keep the plus or minus on there, okay? Make sure you do not do that, all right? So that's what happens if this number here is a perfect square when you are solving with radicals.